Hello, my name is Ginger Krieg Dosier, and I'm CEO and co-founder of bioMASON. Thank you for inviting me here today and hopefully inspire you through the story of bioMASON. Across the world, never has there been a higher sense of collective urgency for climate change action. Awareness as the start for change is front and center for all of us as a global society to visualize global warming and carbon emissions. Building and infrastructure account for nearly half of all global CO2 emissions. 28% is in operational carbon. The remaining 22+% is in embodied carbon, specifically the carbon associated with manufacturing. With the increase of populations between now and 2050, embodied carbon will account for nearly half of all new construction emissions. A building project causes environmental and social impacts far beyond its project site. This is due to material extraction and misplaced CO2 in operations causing the unwilding of our natural environment. Portland cement, the primary ingredient in concrete, is the second most consumed substance on the earth following water. 4 billion tons are produced each year, accounting for 8% of all global CO2 emissions. Portland cement is made by burning limestone for calcium. Carbon is a byproduct, and carbon is misplaced. Our planet doesn't have 20 more years to wait for solutions. And being bad, less bad is not good enough. It is estimated that by 2050, we will no longer have coral reefs due to ocean acidification. Portland cement as an industry has not changed in 200 years. Nature builds cement with positive impact. bioMASON was born out of inspiration, imagining a world where we grow cement. This is an image of me during my first trip to the beach. As a child, I was fascinated by coral and shells and was curious as to how they were formed. I started my career as an architect and became interested in materiality, specifically on how materials for construction were made. I was astounded to learn of the impacts of our planet, but also question why we were making materials in the way of heating, beating, and treating. One late night, after many sleepless nights while interning in New York, I decided to grow a brick. I had just read the book Biomimicry by Janine Benyus and sought a blueprint already found in nature. I started a lab in my second bedroom, and after thousands of iterations, I finally had success at a small-scale masonry unit. I was teaching architecture in the United Arab Emirates, and in 2012, decided the best way to make a global impact was to quit my job teaching and start a company. My goal was not just to have one manufacturing plant that can serve a 500-mile radius, but rather a global solution designed from day one to scale impact and provide further solutions around the planet. At bioMASON, we're here to deliver positive disruption. We are here to revolutionize cement by partnering with nature. By studying the blueprints of nature, we offer a better cement by partnering with nature. bioMASON moved to Research Triangle Park, North Carolina in December of 2012. The next years were critical for achieving non-dilutive funding through the National Science Foundation, Postcode Lottery Green Challenge in the Netherlands, and dilutive funding with early investors. In 2014, we built our first pilot plant to deliver on a significant order for Dropbox's headquarters. Subsequent funding rounds took place, and we began to expand our manufacturing. Last year, we closed on our Series B funding and are currently in our new headquarter location while increasing our plant by 5x this year. You cannot make Portland cement sustainable. The very foundation relies upon extracting calcium through high heat. We went back to the building blocks in nature, biocement, built with calcium plus carbon, powered by biology. We start with aggregate, and in particular, we use waste materials for our aggregate. The aggregate is inoculated with our bacteria and pressed in shape. Similar to how coral reefs are formed, our bacteria mediate the environment for production of calcium carbonate around the aggregate, binding the grains together. A solution, similar to seawater, is delivered over the units until hardness is reached. Our current production is less than 72 hours, and this year we'll be reducing the time in half. After the material has hardened, the composition is the same as natural stone. 85% waste aggregate and 15% biologically created calcium carbonate. Today, our first commercial product is called Biolith Tile. It is grown in complete ambient conditions. It is 99.4% less CO2 than concrete, and it's 3 times stronger than a concrete block. We have several market demonstrations and are in process of many more across the globe. The product can be used vertically, horizontally, used in interior or exterior environments. In addition, the tiles are installed with the same methods used in traditional masonry and can be cut on site. Beyond tile, bioMASON has many other applications for biocement. These include work on living marine cements used underwater with the ability to self-repair. And this funding has taken place through DARPA's ELM project, which is very exciting to be part of, because when you look at the common materials used underwater for construction, concrete is not the best material. In fact, it starts to decay underwater, create microfissures, and start to need repair. So what we did is we saw, okay, well, what's the best material to be used underwater? And we came back to the same solution of a biocement material. In addition, this technology can be used to strengthen soil, such as for helicopter landing pads. We completed some contracts with the United States Air Force on runways used in remote environments. But what is critical for bioMASON to be successful is creating the biggest impact. Our goal is to greatly reduce the construction industry's CO2 by offering planet-friendly solutions for cement. We have an organization of over 38 different disciplines and 58 employees who are growing quickly and expanding our product roadmap. What I want to leave you here today is that we believe cement can be in balance with nature. As a global society, we must rewild our world, restore biodiversity, and we believe to do that through partnering with nature. I look forward to any questions that you may all have, but I just want to, again, thank you all for having me here today to talk about bioMASON, what it is that we do, how we started, and really our drive to make a significant impact on our planet. So a great question. Can it be produced on site, or does it require a manufacturing plant? When we first started, we were fascinated by distributed manufacturing. What's great about this technology is that it can be formed in ambient conditions. So one of our very first plant designs was in a shipping container. And what we imagined was the shipping container having the equipment to be able to press the units out and take into different construction sites. And most importantly, using the aggregates that are already found on site. We still have that model in our plan, but we are building plants that can serve a 500-mile radius currently. But it is a great question. I think that it makes sense for a technology like this to be able to be disruptive, even in decentralizing manufacturing. Another question, what's the biggest scale project to date that has integrated tiles from bioMASON? So we have a current project right now that is over 4,000 square feet. We have other projects that are looking at over 10,000 and one that's using 50,000 square feet. It's going back to part of the presentation. I was going through a timeline of back in 2014 when we decided to build a pilot plant that could serve an order for Dropbox's headquarters. We knew that from day one, what's important is to be able to have real world demonstration. And something that I didn't highlight on too much in the presentation today is how much material testing that we have internally, but also third party material testing. So thank you for that question. I'm scrolling through. how can we help spread the word, especially as an investor? I love this question. I don't know if all of you have watched the most recent documentary by David Attenborough, his witness statement, A Life on Planet Earth. We've never been in a better time for people to have a critical awareness of climate change. And, specifically, we're seeing a lot of negativity and, how critical time is. We don't have much time left. But what I truly hope is that we offer hope and we offer solutions. And I think that what's critical is that we share these solutions and we talk more about what the solutions are, but we also are firm within ourselves of measuring what that impact looks like and measuring it at scale. I think, for companies like us in growth phases, investment is critical. It's critical for us to be able to expand. We believe that technologies like this, and there are many others, and other aspects that are large carbon emitters, require early investment to get them off the ground, to push these technologies. But I think the biggest challenge is that we need to continue talking about the solutions that we have and prevent any apathy that may come in place. Another question. There's currently a resurgence in the use of rammed earth. Is bioMASON a suitable alternative? Rammed earth is extremely labor intensive, but has great compressive qualities. Thanks for that question as well. So yes and no. I think that that rammed earth, used in environments where it is indigenous, where it is a practice that has been done over time, makes sense. You're using the material directly from the construction site, which is the most sustainable practice that you can have. I know with our technology, part of our push is the development for being able to just add water. So with that, there are many challenges along that we're solving. But when we first started, we recognized that we needed to be able to find that substrate, so that 85%. So there's certainly the ability to mix our technology with the materials that are already found on the construction site and go through different application methods within that. That's the easiest thing that you can do is do things directly on these construction sites with making the most minimal impact as possible. Just as a quick side story on rammed earth. So when we first developed this technology, we were trying to figure out what all can we make with this, what all materials can be used. And we certainly were able to use different clay soils from the beginning and not just traditional aggregates or construction waste on that. So I do believe that there are many applications and many possibilities within that. And specifically to be able to make the most minimal impact directly on the construction site itself. Yeah. And then let's see, lastly, based on what you've shown, the product seems to be more geared towards individual masonry units. Do you have solutions for replacing something like poured-in-place concrete slab? Yes. Thank you for that question. That is our drive. That is our goal. Our product roadmap is to start with masonry. It's something that we've developed. We are commercializing right now. But absolutely, for us to be able to make the biggest impact on the planet by abating Portland cement, it is in ready-mix concrete. Thank you all very much for your questions, for your time today. Onward. Thank you again.